You know there's a new kind of heist happening right now, all around us? It's totally invisible, it's all digital, and the target isn't cash or gold. Nope, the target is the mind of an artificial intelligence. Let's get into it.
So this was the bombshell that AI lab Anthropic dropped. And they weren't talking about some minor bug or a small-time breach. They were talking about a massive, coordinated effort to literally steal the essence of their main AI model, Claude. And here's the part that's so wild. The attackers aren't grabbing lines of code. That's not what this is about. They're systematically copying the model's behavior, its ability to reason, to write, to think, all so they can build a clone of it.
So let's really break down the specifics of this alleged AI heist, because the details, well, they're pretty fascinating.
Okay, so Anthropic actually pointed the finger at 3 specific AI labs. And the sheer scale of this thing is just staggering. We are talking about over 16 million interactions, funneled through this sprawling network of around 24,000 fake accounts. I mean, this was no smash and grab job. It was a long, sustained, industrial-level campaign.
So how in the world do you even steal an AI's mind? Well, the weapon of choice here is something called a distillation attack. And I know it sounds super technical, but the basic idea is actually pretty easy to wrap your head around. First off, it's really important to get that knowledge distillation on its own isn't a bad thing. In fact, it's a totally legitimate and useful technique. A big AI lab might use it to train a smaller, more efficient student model using its big, powerful teacher model, maybe for a mobile app or something. It's all about making things run better and faster.
But you can take that exact same technique and flip it on its head for a really malicious purpose. In a distillation attack, the goal isn't efficiency, it's straight-up intellectual property theft. It's an unauthorized way to try and clone a competitor's model to get all its power for just a tiny fraction of the original development cost. And here is the absolute key to the whole thing. The attackers aren't hacking servers. They're using the model's public front door, its API, just like any normal person would. They just feed it millions and millions of questions and then scoop up all the answers. Those millions of outputs become the textbook to teach their new model to act exactly like the original.
So let's dig into the playbook here. How do you actually pull off such a huge data heist without getting busted right away? It really just boils down to a 3-step process. First, you've got to evade the controls. So you create thousands of fake accounts, use proxy services to hide where you are and who you are. Then comes the extraction, systematically hitting the model with millions of prompts. And finally, you take all that data you've harvested and use it to train your own student model.
And to fly under the radar, they use what Anthropic actually called Hydra cluster architectures. Think of the mythical Hydra with all its heads. It's this giant network of accounts that cleverly mixes the bad traffic in with tons of normal, everyday requests. It makes spotting the actual attack almost impossible. It's like finding a needle in a continent-sized haystack.
So what does one of these attack prompts look like? Well, this is the really clever part. A single query can look completely harmless, just like this one. On its own, there's nothing wrong with it. It's just asking the AI to pretend to be a data analyst.
But what happens when that exact same prompt gets sent tens of thousands of times from thousands of different accounts, all trying to poke and prod the same exact capability? Well, that's when the pattern starts to emerge. See, the attack isn't the single prompt. It's the sheer overwhelming volume and coordination.
And this chart just lays out the mind-boggling scale Anthropic is talking about. They're alleging over 150,000 interactions from one lab, 3.4 million from another, and a jaw-dropping 13 million from a third lab called Minimax. That is just a colossal amount of data being siphoned out.
Okay, so why does any of this really matter? I mean, it goes way, way beyond one company losing a bit of its competitive edge. The stakes here are incredibly high for all of us.
For starters, you have massive national security implications. Imagine these stolen capabilities being handed over to authoritarian governments for surveillance or cyber warfare. Then there's the fact that these clones are almost certainly stripped of the original safety guardrails. And on top of that, it totally sidesteps things like export controls on advanced computer chips. I mean, why bother getting the chips if you can just steal the finished product's brain? And let's be really clear about the worst-case scenario here. This could lead to the spread of incredibly powerful AI capabilities, the kind that could be used for nasty stuff like designing bioweapons or creating hyper-realistic disinformation, but completely untethered, with none of the safety features or ethical rules the original creators spent years building in. But, it's not all doom and gloom. The industry is not just sitting back and watching this happen. They're actively fighting back. Let's take a look at the digital defense they're mounting.
The defense really has to be multi-layered. Companies are now fighting fire with fire, using their own AI to spot these suspicious patterns in real time. They're making it way harder to create fake accounts in the first place. And this is a big one. They're starting to share intelligence with each other and with cloud providers to track these Hydra clusters as they move across the internet.
And one of the most promising new defenses on the horizon is something called watermarking. It's basically like embedding a hidden invisible signature into the AI's text. So if a rival model suddenly starts spitting out text that has your watermark all over it, well, you've got your smoking gun, verifiable proof it was trained on your data. So where is all this headed? Well, it's pretty clear we're at the very beginning of a completely new kind of digital arms race. Because even with all these cool new defenses, actually proving who is behind an attack is still incredibly difficult. It's a constant cat-and-mouse game. As soon as the good guys build a better mousetrap, the attackers figure out a new way to sneak past it. And this gets to the fundamental dilemma here. The very thing that makes these AI tools so useful to all of us, the API, is the exact same thing that leaks valuable information about how they work. It creates this permanent tension between making AI open and useful and keeping it secure.
Which really leaves us with this huge, profound question for the future. In a world full of AI copies and clones, a world where it gets easier and easier to duplicate a model's mind, how will we ever be able to prove what's real?